All right, last section in chapter 12 that we're going to cover is on spheres. And within this section, we're going to look at both the surface area and the volume of spheres and hemispheres. So starting out, surface area of a sphere, which you can find on your reference page, is 4 pi r squared. Again, it is 4 pi r squared. And if you look at that, part of that should look pretty familiar, because if you look at just the second part, the pi r squared, that was the formula for area of just a circle. So the surface area of an entire sphere will always be 4 times a circle. So if you have a sphere, like this case, go ahead and try to sketch that as best you can, a sphere of radius 8.2, and you had a circle also of radius 8.2, it would take exactly 4 of those circles to perfectly wrap around that sphere. Okay? So it's just 4 pi r squared. So to evaluate this, as long as you know the radius, you just plug that in where it goes. So for example 1, we would simply say surface area will equal 4 times pi times 8.2 squared. And then grab your calculators, practice typing that in, 4 times pi times 8.2 squared. And we'll keep going nearest 10th like we have most of this chapter. And I will get 844.96. I'm going to bring that up to 845.0 meters squared. Again, since we're doing area, it was just units squared. So that's it for that one. So if you know the radius, you simply plug in, that'll give you your answer. Example 2. We are going to find the surface area of the Death Star if its diameter was 900 kilometers. And that is the diameter according to Wikipedia, as I researched a little bit. So we're going to find the surface area of the Death Star, and we're going to pretend like it is a perfect sphere, even though it's probably not quite. For our purposes, that's what we'll do. So diameter was 900 kilometers. So surface area formula was again 4 pi r squared. So for our purposes, we don't need the diameter. That's what we were given. We need the radius. So if the diameter was 900, think about what the radius would be, and it would be 450, because that would be half of the diameter. So that's what we're going to plug in. Surface area equals 4 times pi times 450 squared. And you could expect that we're about to get a very large number, so don't be alarmed when you type this in if you get a very big number, because we have a very big radius. So 4 times pi times 450 squared. And when I type that in, I am getting 2544690.049, so 0.0. Put some commas there. So if I were going to read that, I've got 2,500,000,44690.0. So relatively large. So that would be the surface area of that. So on your more traditional problems that you have on your assignment, if you're given the diameter, don't forget to have it before you plug it in. If you plug in the diameter instead of the radius, you will get a number that is 4 times larger than it should be. So maybe think on why that would be true. If you plug in the diameter instead of the radius, your answer is going to be 4 times as big as it actually should be. So think on that. A hemisphere is created when a great circle divides a sphere. These function a lot like a semicircle, where a semicircle was created by the diameter. A hemisphere is created by a great circle. And a great circle is, if you have any sphere, a great circle is something that slices through it right at the center. So it's a lot like the diameter of a sphere, but it's an entire circle. And initially, you might think if we were finding the surface area of a hemisphere, that it would be half of the surface area of the full sphere, and the full sphere was 2 pi r squared. But if you look at our formula, I've got a 3 written here, which was not a typo, it was very intentional. The 2 pi r squared is part of it. So the outer, that curved part, would end up being half of 4, which would be 2 pi r squared. But when you slice that, you end up with this new circle on the bottom that wasn't there to begin with. And that circle would be pi r squared. So you end up having the 2 pi r squared for the curved part around the exterior, plus the other pi r squared, which is this circular surface on the bottom. Add those together, and that's where the 3 pi r squared is coming from. Okay. So if I were to tell you that the radius is 32 inches, those would be the same. You plug in 3 times pi times 32 squared. So our surface area will be approximately, type this in with me, 3 times pi times 32 squared, 9,651.0 inches squared would be our round. So again, surface area of this hemisphere is 3 pi r squared, opposed to 4 pi r squared for the whole thing. Volume of a sphere, here's our formula for that. Volume of a sphere is 4/3 pi r cubed. So the fraction here is 4/3 pi r cubed. And for example 4, we are going to find the volume of the Death Star. So probably going to want to refer back to example 2. Info that we were given in example 2 was the diameter was 900, which we don't need that here either. We still need the radius, which we figured out was 450 kilometers. So to find the volume, once I know the radius, I'm going to simply plug in. So 4/3 times pi times 450 cubed. So make sure you can find out how to cube something on your calculator. And again, don't be alarmed we get a really large number because this is a really big thing. 4/3 times pi times 450 to the 3rd power. I am getting approximately 381,703 507.4. And I'm still saying approximately because if your calculator is anything like mine, like this is exactly what it said on the screen, there's more decimals behind the 4. The issue is your calculator doesn't have enough space to display all the digits. So your calculator rounded it for you automatically just because there wasn't enough room for all those. So by reading that, I would say we had 381,703,507.4 kilometers cubed. So a very massive imaginary object. And that's how you find volume of a sphere. You just plug in the radius. And that is the lesson for spheres, pretty short stuff. These, I would argue, are probably the simplest of our solids to work with, because if you look at the volume formula, the only thing that we knew, or need to know, excuse me, would be the radius. If you look at the surface area of either a hemisphere or a full sphere, again, the only thing that we need to know is the radius. So unlike cylinders or cones or pyramids or prisms where there are multiple components to the formulas, spheres, radius is in. So I think these will go relatively smoothly for you. So if you need to rewatch any of it, feel free to do that. Otherwise, spend the rest of the block working on your 12-6 assignment, which will be due next time. And then next class, you'll be working on the review for the Chapter 12 test, which will be 2 blocks from today.